And welcome back everybody to Luke Learns Coding as we do live algo challenges in this scheduled LeetCode prep for technical interviews site. You can follow along in the description. Yesterday we got our butt kicked by number 2 valid parentheses, which was supposed to be easy and take 20 minutes. It took us, I don't know, an hour and a half with some people helping. So not a great start, not a great sign, but we gotta take things into perspective. 1, these are LeetCode challenges, they are hard. 2, I mean, these are technical prep interviews probably for some of the harder companies like Fang, those big tech companies, which isn't really my goal anyways. Really the goal is to learn here, to get better as a programmer, learn some like more computer sciencey stuff like big O notation. A lot of the boot camp was, just focused on web development. We did do some algorithms, and they did encourage us to do algorithms, but there wasn't really a ton of time to go dive deep into them. So I guess what I'm trying to say is that this isn't necessarily for I want to prove that I'm the best programmer and developer out there and start applying to Google tomorrow, but to just learn and to grow. And yesterday, even though it was a pain, half the problem was just me not understanding the challenge really. So that was part of it. We solved it in many different ways and then realized, oh, this test case isn't valid. This test case isn't valid. So there's definitely a lot of back and forth, but I had a lot of fun. So thank you guys for showing up yesterday. And hopefully today maybe it's a little bit easier, but if not, that's okay. I did learn about getting to use the data structure of stacks, which we went over a little bit in the bootcamp of stacks versus queue. Stacks, I think I said it wrong yesterday. I think it's supposed to be last in, so like as you're stacking things on top of each other, the last one that you stacked is the one that you're going to first remove, versus a queue is more like a line, so like people lining up, bloop, 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 bloop. The first person that got into line is the first person to leave, and etc., and then you move up in a line. So yesterday we got to actually practice. Even though I knew these theories, I haven't really faced them in algorithms yet like that, where it was such an obvious, like, yeah, use this data stacking where we want to match the last parenthesis that came into our array. Let's match it to this next one that we're checking. So that was cool to learn about that. But let me send out some alerts that I'm going live here while we wait. Not that I don't think anyone's here yet anyways, but if you happen to be here jumping in, feel free to say hi. Tell me how your week is going. And I hope you guys are having fun programming as well. Love to hear if you guys are programmers, what you guys are building, what you guys have been up to. Anything fun? My brother-in-law and I are starting up a coding podcast, which I think is going to be pretty fun. Which I think is going to be coming out the first episode on Friday. Okay, one more message and then I think we should be good to go here in a second. And let me throw one more out. Actually, I lied. Maybe I'm just delaying so that I don't have to do these algo challenges live. The more I delay, the less of these challenges I get to do live and the less I get embarrassed. Because okay, I'm pretty used to it based on my time doing gaming streaming. There's lots of times where I made horrible plays that made me look pretty stupid. So I'm okay with it. Cool. All right. I think we are golden. Let's see if we can do it. I'm a little bit afraid to pull up the challenge, but this today is number 3, merge 2 sorted lists. What are we working on? Okay, at least they give us a nice little graphic here. That's cute. You are given the heads of 2 sorted linked lists, list 1 and list 2. Merge the 2 lists into 1 sorted list. The list should be made by splicing together the nodes of the first 2 lists. Return the head of the merged linked list. Okay, so we got 2 lists. You're going to sort them into 1. This should be made by splicing together the nodes of the first 2 lists. Okay, so example 1. We got a 1, 2, and a 4 in the first list, a 1, 3, and a 4. So then we end up with 1, 1, 2, 3, 4, 4. Okay. Nothing too out of the ordinary there. I wish they would give us sometimes better examples in here, but that's fine. The number of the nodes in both lists is in the range of 0 to 50. Both lists 1 and 2 are sorted in non-decreasing order. Okay. The list should be made by splicing together the nodes of the first 2 lists. I'm not sure if I don't think they actually mean the splicing method, but I guess we'll find out. Okay. Definition for singly linked list. Do they want us to do linked lists? Couldn't you do it without a linked list? We went over linked lists a little bit in the very end of our bootcamp. So we did them. Do I remember how to do them? That is the question. Yeah, I'm not sure if we're, I mean, if they're giving me a definition for a singly linked list, you'd think, and talking about nodes, you'd think that they would want us to do that. But I'm not sure, because most of the nodes that we worked with were 1, not merging 2 different lists. So my mind more went towards just looping through and checking the lists against each other. I'm sure there's like a really built-in method too that'd be like, I feel like Python probably has a built-in method where we could just, I know they do, where you can put them all in one list and then just sort them like that, but I don't think that's the point of the solution. Global Nobles, what's up? Speaking a foreign language. It does feel like I'm speaking a foreign language, doesn't it? Trust me, there's still times in coding, I've been studying for what, 8 months now, which is not a long time, but there's still concepts all the time that I'm like, this sounds like you guys are speaking a foreign language. So I get it, you know. That's why I want to do some more like beginner videos as well, but right now, in the midst of looking for a job, I kind of need to be focused on prepping for a job. So that's why I'm trying to do these technical interview challenges, but they're not easy. They're kicking my booty. It has been a while. How have you been? How has it gone? Okay, well, I'm trying to decide how I want to do this. If I want to do it the cheating way, if I actually want to try to do a linked list. But I don't know if I'm going to be able to do a linked list live. I might need to like go back and watch the videos that we did going over singly linked lists. Joel, help me. What's up? How's it going, Joel? What you up to this morning? Oh, you're in Portugal? Nice. What? How's it going in Portugal? I want to go to Portugal. Ask ChatGPT. Do a linked list. I forgot how to do linked lists, man. It's been 3 weeks, 4 weeks. It's only been like 3 or 4 weeks since we went over them. Have you done this challenge? All right, I just feel like I need a. I know, like, okay, there's a head, there's a node. It's gonna be way more than I was wanting to look up. But did we do it where we merged 2 different lists? This is Greg. Okay. I thought so. I remember you guys mentioning going over there. Oh, well, Joel, if you've already done it, just tell me how to do it. Are you talking about up here? They do have a nice definition for me already. Merge to sorted. To sorted lists. Let's just get the challenge out here. We're not going to do it in the class. I just like doing it in a normal function and then uploading my stuff into them. Okay, so list node object, then we make the class, obviously, and then set next. So what did we do? I remember in class we had like the assassins, we had the kings, and we set like the next node is this. And I remember going through it. I remember like going through like the tree options to see like if it's greater than or less than, you know, based on that we would go to there or to there. You did it in Java. Okay, if you did it in JavaScript, that's still, you know, whatever. Like, still the same thing, man. Come on. Looking for a side gig? I'm looking for anything right now. So basically, I'm in the midst of the job hunt, but my brother-in-law and I are also starting up a little side gig business to basically ask around connections that we have to do freelance contract work. We're even applying for a grant or two to build out some different web applications and databases and stuff. So we'll see if any of them pan out. But yeah, any work, you know, based on the job market, what we're hearing back right now is that it's going to be a quite a long process just because the economy is rough. Tech is a little bit rough still. So, you know, we kind of have to be patient on the job front. So I'm like, yeah, anything on the side is a great start, you know. You any good at the Apple Watch? I have not worked at programming an Apple Watch, I will be honest. But explain to me what you're looking to have done, and I can research it and tell you if it's something that I could look into. But yeah, I don't have any experience right now, no. It sounds fun, though. Oh, so if we do node.next, then we can look at, can we just put them in one giant list and then sort them that way? Yeah, because the list should be made by splicing together the nodes of the first 2 lists. So we could just cram the lists into one list, right? And then sort through and link them together. Yeah? Maybe. Actually, I need to... Let me put the example there. I like putting it all in VS Code. It's just so much easier. I'm more familiar working in VS Code than trying to do it on the actual site. I don't know if you're like that as well, Joel, but I hate typing in their sites, and it sometimes like freezes and stuff for me too. So this shall be just easier, hopefully. Iteration over contemplation. Okay, thank you, Aaron. I'm also trying to do these challenges in Python because I've been mostly building something in Mern right now. So it's kind of fun and difficult to go back and forth between the two. It's hard. Yesterday I kept doing things. I'm like, okay, this is the method. This is the syntax for JavaScript. Nope, I'm not in JavaScript. I'm in Python. Okay. So default, so we have self.value, self.next. So we have the node, and then didn't we make another class? Right? Which would then take in the node. What did we call that? I keep thinking about Aaron's king and assassin, but I can't remember what we actually called him when we weren't calling him that. Yeah, I lost some Python skills as well. I'm building them back up because I think the more I apply for jobs, the more I realize, okay, I can do front end, but a lot of the jobs I'm seeing, I don't know if you see this too, Joel. It's like, okay, in theory, front end is not necessarily about design. Like a lot of the times it should be about you're working with a designer, UI, UX person, and just building what's requested of you. But a lot of the jobs I'm seeing is like a hybrid, like you're the front end, but you're also like, you need to design these things yourself. And I'm like, I can make something look good, but I'm not that creative enough to be the design person myself, you know? You don't need that here. The king will be just the first instance. Okay. Okay. So, actually, we do need this class before. Do we need the class before the function? It might not matter. Okay. So if we have list 1 and we have list 2. Are we making... So basically... Basically the head, we're gonna start with the first value. So I'm gonna make some comments here. Start with the first value as the head slash, it's the head, okay? Then what we're gonna do is check next in the list if it's less than or greater than. If less than, add, so it would be in the front of the list. So that would be the new head, right? And then if it's greater, it is sorted from, yeah, okay, from least to greatest. If it's greater, then add to back of the list, right? Seems simple enough. All right. So I guess, do we need to even? I don't think we need to add the lists together. We can just make the function go through list 1 and then go through list 2, right? Okay. So let's see if I remember how to do this. So it wants us to give it an object for, so it's either gonna have a value of 0 or we have to give it a value, and it's gonna start with the next one. So, oh baby, okay. Can we just start with a head node? New, what is it? Python new class? No, that's JavaScript. I told you. I think it's still new though, right? Well, we should probably be doing this in a for loop, right? Isn't it new? I literally forgot how to make a new new class. Google some different sorting algorithms and you can do a quick sort here. It's a quick one. Well, hey, by the way, hello Thomason, how you doing? Good to see you again. I mean, yeah, it would be pretty easy to look up a built-in method, especially in Python, but I think it's based on what it was describing, it wanted us to do a singly linked list, which I have not worked in for a fat minute. Okay, so I don't even need the new. See, I keep trying to do JavaScript. Yeah, baby. I don't even think we need to make a head node because we just need to compare it to the last node. So I think if we just make a for loop here. For num in list 1. If you get a job remote, say Google, Facebook, Apple, totally suggest Portugal. Dude, that would be awesome. I don't know. My wife would love to live in Europe, but she would also have to start like some online counseling. I don't think she would be able to get like a counseling job in Portugal. So that would be interesting. All right, let's set up a test case here. Merge two sorted lists. We got. We're gonna print this, just so we have something that we could be working with here. All right, so let's just, for funsies, make sure we're getting what we're getting. Print out those numbers, 1, 2, 3, 4, or 1, 2, 4. Yep, cool. Wife could work at the local school here in Norway. Where's Norwego? Is that in Portugal as well? Contractor in the U.S. Navy in Spain? That's true. I don't know if she would want to do that. I think she's really loving being a school counselor, but she would also be willing to be a private practice counselor. But yeah, I don't know exactly how that would work, or if she would want to do like the US Navy contractor. But I mean, there's a lot of online counseling now, so it's possible. It's possible she could just do online counseling from Portugal with, you know, Oregon and Washington clients that she already has built up. But also she would be doing that at like potentially like in the middle of the night. So I don't know how that would work, you know. Okay. I want to print this now and make sure, is this what I'm... Object. Okay. So we have an object. We need to save it as a variable. So we do need a head and we do need a runner. Pretty sure that's what we did. So let's make header equal header. It should just be head. And then print head dot next. I just want to make sure this is. I'm trying to remember. I'm trying so hard to remember right now. Oh, oops. List 1. Head dot next. Head dot next should be none because we haven't set it to anything. Okay. So we'll start the head as the first list. And Yeah, okay. So then if we do that though, we can't go through every single number because we already used the first index. So I think we need I in range of starting at index 1 to list 1 length. We're just trying stuff, guys. Why can't I do this? What did I screw up? Was not closed. Oh, I forgot one parenthesis. Ha! I was like, I'm pretty sure this is how to do it from what I was doing yesterday. Norway and Spanish. Let's go. Dude, yeah. Happy hour all day. That's awesome. So while it's visualized in an array, the structure is actually a linked list, so you'll need headers and runners for both lists. Headers and runners for both lists? Does it need to be both lists, Joel? Because I was thinking you just set up one head and then go through both lists because we're merging it into one list. Right? Or am I off in that? I mean, I'm just gonna keep trying it. You can tell me if you have any other hints, but. And then last time I know we did a lot of while loops in. Do we need a while loop instead of a for loop? So right now, I would be basically looping through everything in the list, but I don't know where it's going to start or stop, so that's where I need a while loop, right? One sorted list. So I guess I don't know why I would need 2 headers and 2 runners, but I'm not the one that solved this yet. Well, let's start with while true and then break it, I think. So you need to compare the first value in line from both lists. Huh. So I guess I guess I don't know why you couldn't just. Well, I guess if you go through only list 1, that's kind of right. That's like list 1 is already sorted, so why would we go through list 1 and sort? So I guess I get what you're saying, because if we just go through list 1 and then sort, then we'd go through list 2 and sort into that list. But that seems kind of silly, because why would we sort this when it's already sorted, if that makes sense? But they're in an array, they're not in a singly linked list yet. So what you're saying is, yeah, we want to compare 1 to 1, 2 to 3, all that jazz. But I guess how do you put them in a singly linked list if you have 2 heads and 2 runners? Right? Doubly linked list. That's what this is. Gosh. I should really go back through and do all the other singly linked lists problems and assignments from Coding Dojo. They had a few. Okay, so if we have 2 different heads, start at 1 to 1, and then do we check I guess I'm I'm really struggling with the concept of having two different heads. Because I think of singly linked lists of what we did of just that one list. And adding to the front or back of it. Because we could add, I guess... Like, I kind of just want to start with one head and then go back and forth between these two lists to see which one's larger and which one's smaller. Also, do we know if... I can't remember if the lists are the same length. I don't think so. Did it give us any examples where they're different? So I'm going to guess, yeah, okay. So this one has a different size. I don't know. I guess I'll just create a singly linked list like I was thinking of at first, and then maybe see if it works and then refactor it into two heads. So this is probably not the best way to do it, but just for the sake of me even trying to remember a singly linked list, let's just go for something. What did you say earlier? Iteration over contemplation? Yeah, okay. So we're going to loop through. We already have our head, which is going to be the first number of the list 1. I guess we can make the check to see if there is a value there. But let's do edge cases later. Let's just start with this first one and not worry quite yet about edge cases. So we have our head, which is going to be from the first list of 1. And then let's see. I think we did runner outside of the while loop, right? Runner equals head for now, right? And then in the while loop, that's when we're going to update runner to runner.next. So what we want to check for is the next one in the list, which for, I guess, because they're already in order, it doesn't really make sense to do all this. It does make sense to do all this for the second list. So let's just try this. I know head.next. This probably isn't what I'm supposed to be doing, but I just want to try it. So we're going to go through. We're going to take each index value and then add that to the head.next. And let's just print this out so that I can visualize it for a second here. None type object is not callable. What did I do? Oh, I need to make this into an object, right? Not just the value. Object is not callable. What did I do? Isn't there? Okay, hold on. We're gonna print this list of I, just make sure I got that right. 2, 4, we got the head. Okay, so why can't we do, we got head.next. Oh, head.next equals. I think I was putting it in like parentheses, like a function, right? So list node. So we're going to set it equal to a new node, which is going to be the value of .I. Okay, so obviously that's going to be the same for now, but if we do head.next, we should also get an object. Do head.next.value, we should see 2. .val, not value. Okay. Head.next.val is 4. No. Why is it 4? It's head.val. Let's see what that is. It should be 1. Alright, Global Nobles, thanks for coming by. Have fun in Portugal. Let me know how it is. I want to hang out in there, but you know, right now, don't think it's gonna happen. Oh, well, we do need a runner because now we're just setting head.next to the next thing. So runner equals head. So just kidding, we do need a runner, and it's gonna be runner.next equals that, and then we need to set the runner equals runner.next. So I'm starting to remember a little bit about my linked list. A little bit of it. We're on our way. All right, so now we have a node. Head next value is 4, and there should be no.next. So let's just check that as well. Make sure, yep, none. Okay. So now we have this array into a singularly linked list through that for loop. And then we can do another one with the second list and sort them. Again, I don't know if this is the best way to do it, but this is what I'm trying to do without looking into more singly linked lists. Because LeetCode passes in lists, you may want to convert those arrays to list 1 and list 2. Alright, sweet. I'll see what they see. I'll see if it's different in Python. But anyways, Joel, thanks for popping by. I hope you have a good day. See you later. Peace. List 2 for num and list 2. Okay, so this one, you're on your way. Thank you, Joel. Take care. We're gonna make a while loop. And this time, this is maybe where we make the second head. I mean, I guess we could overwrite the first head, but I think for simplicity's sake, let's just start off with list 2 being a different head and see if we refactor this at all. We can keep the same runner because we can just, well, can we? Should we switch the runner to, well, maybe we should just switch head to the next thing. Or is that, no, that's going to throw it off because we need to keep, so maybe we don't need a second head. Maybe we just axe that for a second. And we want the runner now to be the list node, maybe, of list 2. So if we go through each of these numbers and then do a while true for now, we might change that. I think we did a while loop that we have to break when there is nothing left at the end of the list. So what we want to do is check our runner or do we make I think our runner needs to be ahead again because we want to check against this first guy. So actually, let's take rid of this guy. So our head should be this first guy again. In fact, let's just make sure that I'm thinking about this correctly, and let's just print it out, because why not? Head.val should be 1. Alright, so even though we did that for loop, the head is still the same, because we just sorted the list 1 into a singly linked list. And then while we're going through this loop, we want to check, is the if, okay, so let's start with an if statement. We're going to do if the runner we want to check the value of the runner, which is our head, which is 1, equals I think, oh, I think what do we want to call this? New, let's make a new node here, and I think that's where we can bring in this guy. We don't want to hard code the first index though. We want it to be the number that we're looping through. That way we can check if the runner is, if it's equal to the same value as new node, then we can just set it to the runner dot next, right? Because if they're the same, it doesn't matter if it goes behind or in front, just like as long as it's right next to that previous value. So runner dot next equals new node. I can't remember if that changes all the next values, how that works. But let's just test this for a second and see if we even get into this. It worked. Because the first values are 1 and 1, so they should be, code is already, oops, I didn't break. So let's print and break that. Code is running. Stop it. Alright, so we're not even getting into that. So let's move the break statement outside just to make sure it breaks regardless. List index out of range. Oh, we're not doing a list index. We just want the num. Because we're not doing index and range, we're just doing a simple check each number of the list. So we should just be able to make a number from our list right in there, and then now we should be getting into it worked. Cool. So if we do something like this and print the head, should still be an object. Head dot next isn't head dot next dot val. It's 1. So we have our head is 1 and our, oops. Hi, buddy. Pippin's trying to join me over here. He's bored. He's like, why are you coding? Get off your coding and pet me and throw some toys for me. Yeah. Go boy, just lay down. Okay, so do we still have a dot next dot next? Like, that's the part I don't remember. Yeah, okay. So because we changed the dot next of the head, that then, oof, we need to change first the head dot next to be the dot next dot next. Oh my gosh, I can't remember now. Okay, we're working through this. Right now we overwrote the dot next, so we had a node at 1, we had a node at 2, 4, and then we just made a new node 1 and 1. But somehow we need to get the 2 and the 4 back attached to the next one, if that makes sense. So the first we need to make it so the head, basically we need to push everything away in the list so that we can add something into the middle of the list. I'm trying to remember how we did that. I remember it's a lot easier to add something to the end of the list or to the beginning of the list. Dang, okay. So before setting and overwriting the dot next, what we could do is the new node has a new node dot next has the value of, so if let's say the runner it starts off as the head, we want to swap this guy to be here, but if we say, hey, this guy's next is the runner's next, which is 1, his next is 2, so now the 1 is linked to the 2, which it should still be linked to the 4. So I think that's how that works. New node dot next equals runner dot next. So instead of overriding the runner dot next, we set it equal to the new nodes dot next, and so I think they should still be linked. 111 or 112. Oh my gosh, am I a genius? Am I super smart? Let's go. It's still linked together. Okay, I'm starting to remember. Thank you, Aaron and Jonathan, who taught us singly linked lists for like 2 days, I think. Oh yeah. Cool. So that's working if they're the same value. Obviously, we gotta account for the other things. So yeah, for now we're checking if it's equal. So let's do an else if to check if. We'll just copy and paste this guy and take it to, let's count for greater than. So if the new node, oh, it's elif, right? Elif. I think elif sounds funny. For some reason, it makes me want to say, under my elif, a. Maybe Rihanna's a programmer. I don't know. Okay. So if the runner, which is the node that we're looking at, so let's say we're at 1124 now. We updated, and then we got to update as well our. So I think we can put the break here now. Get rid of this print statement. And then we also need to set our runner to be the runner dot next, because if not, then we're not updating. Yeah. We need to make sure that now we switch to, okay, if it's 1 and 1, that we switch to make sure our runner is now this one. And now we're looking at 3, how to sort 3. So if the runner, which is now 1, if the runner is greater than 3, which it's not, so let's go less than, just so we can test out this case first. So 3 is going to be greater than 1. but it's also going to be greater than 2, so we can't just set it above it. We need, oops. We need to set it to check as well if it's at the end of the node. So if, there's a lot of if statements here. If the runner dot next is none, then we can just say this largest value is going to be at the end of our list. So it should be runner dot next equals the new node, and we'll just print this shouldn't be here, because we shouldn't be at the end of our new node because we have 1 1 2 4. Okay, so I'm glad we didn't print that. And then I think we can just do an else, because it's either empty or it's not empty. And if it's not empty, I feel like I'm repeating a lot of code, because then if it's not empty, we'd want to go back to checking, right? Can we just continue? Finally made it. So if it's greater than this next value, 1, so 1's next value is 2, 3 is greater than 2. So so we have to put it near the end of the list of 4, but not past 4. So if it's none, then we can just set it as, yeah, that's not, we can't just continue. That's not going to do anything. Well, it could work if we also have a case of if it's less than, right? Because 3 is not going to go at the end of the list. So we do need that case now of the runner value being higher than the new node value. Okay, so if runner.next isn't none, then we don't necessarily want to set it here. We just want to continue going back to the next iteration of the while loop to check if the new node value is now different to the runner.value. But I do think we still need to update the runner, right? So runner equals runner.next. So it still should be an infinite loop right now. Yeah, because we don't have any case to right now check. Else, the only other option between them being equal and then greater than, of course, is the new node being less than, which is good because now that we'd have a case to go 3 before the 4. So because we're sorting already sorted lists in ascending order, if the new node is less than, then we should just be able to place it right there. Runner.next equals new node. And then, but we need to do what we did before and set the new node next to the runner.next. So maybe we do need to check. Well, okay, so if our runner is 2, blah blah blah, 3 gets put after that, it would go through the while loop, and then 3 is 3 less than 4. yes. So if 3 is less than 4, then we want to make sure 4 is still attached to our new node, and then 2's runner.next is the new node. I think that's enough code there. I think we can just add a break statement here as well. Oh, baby, I don't know. Okay, so we didn't hit an infinite while loop. It did break. But it never made a print statement here. Pippin, leave him alone. Pippin, come. Come here. Pippin, come here. He's trying to make our old dog mad. Do you need some attention? Oh, you're too heavy to lift up here anymore. You're too big, buddy. Say hi to the stream, though. Say hi. Oh, okay. Just gonna lay on my keyboard, huh? He's getting real big. He's getting... It's almost like 35 pounds now, maybe. We got him at 17 pounds. Okay, okay. Okay, come here. You can't bother Reggie. You can hang out with me. Or you can go get your toys. There's a bone right there. I'll be down in a little bit, okay? Oh no, what happened to all my code? Whoa. Oh, I'm just looking at the... I was like, what happened? I typed a bunch of random stuff, I guess. Stop it. Here. And let's just throw in some print statements. Just to see where it's going. So runner.next in the else. Okay, so it is getting into the places we've been making. So now if we print well, actually at this point I think we can just return our head node test and just run it, and then we can print test and see if we get that head. Buddy, he's trying to rip up his bed now. What a crazy boy. Let's make a while loop to see if we can go through all these. While test.next not none. I think we can just still do the exclamation like JavaScript. No? Well, not. No, let's just set it to while, and then if it's not true, it will break. Print runner equals test, print runner.val, and then runner equals runner.next. Pippin, no. Hey, Reggie, no. Nancy, they're fighting. No. Reggie gets up here. You don't get up here. Go get your toy. Hey! Okay. It might be into stream time. No. Man, trying to deal with a puppy and an old dog is difficult. Well, we were very close, but as you can see, I'm getting attacked by 2 dogs right now, so end it now, but we'll finish it tomorrow. No. Alright. Thank you, guys.